Hello everyone. Our today's A-level topic is the equilibrium, and here are some more examples which we can discuss affecting the different factors. For example, we can judge the effect of different factors on both of these two equations. For example, first equation is the decomposition of hydrogen iodide into hydrogen and iodine. This process is endothermic, and oxidation of sulfur dioxide to convert into sulfur trioxide is exothermic reaction. Now, one by one, we can discuss the effect of concentration. That is the same for both of these equations. If we will increase the concentration of hydrogen iodide in the equilibrium mixture, then the quantity of hydrogen iodide will decrease and the quantity of hydrogen and iodine will increase to restore the equilibrium position once again. Similarly, in the second equation, if we increase the sulfur dioxide concentration, then the equilibrium between sulfur trioxide and sulfur dioxide will be disturbed. To restore the equilibrium once again, the reaction will move in the forward direction, and the increased concentration of sulfur dioxide will be automatically shifted into the product, and sulfur dioxide concentration will decrease and sulfur trioxide concentration will increase. This is the effect of concentration. Now, if we discuss the effect of pressure, in the first equation for the decomposition of hydrogen iodide, as the number of moles of the reactants and the products are equal, the number of moles of hydrogen iodide is 2 and the number of moles of these two reactants is also 2. That's why as the volumes are same, so there will be no effect of pressure in case of first equation. Second, here it is the oxidation of sulfur dioxide to sulfur trioxide. If we look at the equation, the reactants has 3 volumes or 3 moles, while products have produce 2 volume or 2 moles. As the volume is decreasing, it means that on increasing pressure, this reaction will move in forward direction to restore the equilibrium position once again. This is the effect of pressure, and the similar will be discussed all the time. For example, if we write this equation N2O4 and this gives 2NO2. Now, what will happen for this reaction if we will increase the pressure, as the reactant has 1 volume and the product has 2 volume? If we will increase the pressure on equilibrium mixture, then definitely this NO2 gas will change into N2O4 and the reaction will move in backward direction, or the reaction position will be shifted towards left. And this is the effect of pressure. Now, the effect of temperature. If we look the first equation, it is endothermic process. It is indicating endothermic process. If we will increase the temperature of the surrounding, for this reaction, automatically heat energy will be absorbed because the process is endothermic. It means that the more hydrogen iodide will be decomposed and reaction will move in the forward direction, or the position of the reaction will move in the forward direction, and as a result more hydrogen and iodine gas will be produced, and as a result the overall endothermic process on increasing temperature will move in the forward direction and more products will be formed. The second equation is exothermic reaction. Exothermic reaction, this is indicating that during this process heat energy is released. If we increase the temperature of the surrounding for the second reaction, definitely the reaction will be slowed down because the heat energy is releasing during the chemical reaction. If we provide the heat energy, if we increase the temperature of the surrounding, definitely the reaction will move in the backward direction or position will be shifted towards left. But still, in industry, we compromise this situation and we maintain 450 degrees centigrade temperature for this reaction. Why? This is because the catalyst used is V2O5, vanadium pentoxide, vanadium 5 oxide. Now, this temperature is maintained or increased just to increase the activity of this catalyst, because this catalyst at lower temperature deactivate and doesn't play a role as a catalyst in this reaction. That's why we know that the process is exothermic. We compromise in the industry to speed up the chemical reaction. Just to increase the activity of the catalyst, we increase the temperature to the optimum condition, that is 450 degrees centigrade. Now, this is the effect of temperature. And the effect of catalyst is, obviously, we have as already discussed that the catalyst for the forward reaction and the same catalyst will be the catalyst for the reverse reaction. That's why catalyst will never change the quantity of reactant or product, just it reduces the time for the establishment of equilibrium between reactants and products. These are the some examples which can also enables us to understand the effect of different factors on the equilibrium processes. Now, next is equilibrium expression and equilibrium constants. Equilibrium expression and equilibrium constants. Consider this is a general reaction. These are A and B reactants, and these small letter A and B represents the number of moles of these reactants. C and D are the products, and the small letter C and D represents their number of moles. Now, whenever we will write the equilibrium expression with respect to equilibrium constant, this is called as an equilibrium constant, and C stands for concentration. Now, equilibrium constant is equal to the ratio between the product of the molar concentrations of the products to the product of the molar concentration of reactants raised to the power number of moles of all these reactants and products. This expression is used when we are dealing with the concentration, because these brackets means concentration, which is mole per dm cube. This is the meaning of these brackets. And if we want to find out now units, consider these two equations for the unit calculation. If we put these reactant and products into the equilibrium constant expression, we will get just like this. Kc is equal to, what are these? These are hydrogen H2 molar concentration, then NI2 molar concentration and then HI molar concentration square. Now look at this equation. If brackets indicates mole per dm cube, this then mole per dm cube for iodine and now mole per dm cube for HI, hydrogen iodide. Now this is also containing power 2 and this is also power 2. It means that all these values of reactant and products will be cancelled out. So there will be no unit for this reaction. It means that from this equation we formulate a general rule that whenever the number of moles of reactants are equal to the total number of moles of the products, then there will be no unit for the equilibrium constant. But if we consider the second equation and putting the values in equilibrium constant expression, what we will get? How we will calculate the units? Now, for this second equation, Kc is equal to what we will write here? SO3 molar concentration, as 2 moles are there, becomes square, divided by SO2 concentration, square, because 2 moles, and now O2 concentration raised to power 1. It means that 2 power units will cancel out and what left? We will get only O2 molar concentration. This can be written as 1 over mole per dm cube, which can be written as quite easily dm cube per mole. This will be the unit for equilibrium constant for the reaction for the oxidation of sulfur dioxide to sulfur trioxide. Now, if we apply the same formula for this reaction, how we will get the unit? Kc is equal to NO2 molar concentration square over N2O4 molar concentration. Means we can write down mole per dm cube square and divided by mole per dm cube only one time. It means that one quantity can be cancelled out, only one quantity left behind, and we will get the unit for equilibrium constant, in this case mole per dm cube for this reaction. This is quite obvious that using equilibrium expression, equilibrium constant expression, unit can also be calculated quite easily. Now, next is we can use this equilibrium constant expression for the calculation. The most important point in this regard is if the concentrations of reactants and products are given at the equilibrium point. When the equilibrium is established, then just we have to take the values of reactants and products and put into the equilibrium constant expression, and then by calculating we can easily calculate the equilibrium constant value. But if the concentrations of reactant or product are present but the equilibrium still is not established, then we have to calculate the values at equilibrium point, and then those values will be used in equilibrium constant expression for the calculation. For this purpose, we can solve some of the examples which are given in the resource book of O level, A level. For example, in case of the reaction is taking place between this propanone along with HCN, and equilibrium is established, and we will get what? CH3COH, CH3 and CN. Propanone cyanohydrate we get, and this is the product. A mixture of 0.05 moles per dm cube of propanone and 0.05 moles per dm cube of HCNs are reacted together to reach the equilibrium. At equilibrium, the concentration of the product is at equilibrium, the concentration of the product is 0.0233 moles per dm cube. Now, it means that these are the initial concentration when T is equal to 0. It means that reaction is not started yet. But when the reaction starts at T is equal to equilibrium, then the concentration of product is this much. As the ratio of this product is 1:1 with both of these reactants, automatically what we will do, initially at 0, the concentration of the product will be 0. At equilibrium, this is the concentration of the product. But this product is obtained from this. Automatically, this concentration will be subtracted from both of these values, and we will get 0.05 minus 0.0233. And similarly, the same will happen with this 0.05 minus 0.0233. What we will get? We will get the answer as, and this will become 0.0267, and the same amount 0.0267 we will get. Now these values are values of equilibrium point. Now these values will be utilized to find out the equilibrium constant expression. Now we will calculate Kc. Kc will become 0.0233 mole per dm cube and divided by 0.0267 square. By solving, we will get the answer 32.7. This is the equilibrium constant expression. And if we find out the unit, then for one bracket we will put mole per dm cube, and for two brackets we will put mole per dm cube and mole per dm cube. It means that 1 mole per dm cube will be cancelled out, and we will get only 1 over mole per dm cube. So the unit will become dm cube mole inverse. This will be the unit for this dm cube mole inverse. This is the equilibrium constant expression for this. I have explained the whole concept present using this equilibrium constant expression. I thank you all.